Leveraging simulation and virtual reality for a long-term care facility service robot during COVID-19. This work was presented at the Symposium on Virtual and Augmented Reality, and you can find the corresponding paper in the reference below. Today, Canada and many other countries are facing several challenges to ensure the well-being of seniors and people living with disabilities. For example, providing high-quality care to seniors and adults with developmental disabilities presents challenges associated with the high variability of conditions within that population and the limited resources available in the healthcare system. Canada also faces challenges related to its aging population. In 2017, seniors aged 65 and older accounted for 16.9% of the population, and this number is expected to grow to 24% by 2036. The census of 2016 also shows that 7.6% of seniors lived in collective dwellings, such as long-term care facilities. Regarding disabilities, 755,000 Canadians have some sort of cognitive disability. Around 3.9% of Canadians suffer from a learning disability, while 1.1% live with developmental disabilities. This sector of the population also suffers from inequality. It is estimated that 75% of working-age adults with an intellectual disability in Canada are unemployed and 70% live below the poverty line. On top of that, the world is facing several challenges in all spheres due to the COVID-19 pandemic. For technology development, some challenges are related to limited access to long-term care facilities, which was established to protect the residents. This hinders data collection and delays the delivery of emerging technologies. Emerging technologies, in combination with welfare, are addressing these challenges. For example, a study with 109 participants with developmental disabilities suggests that assistive technologies are beneficial to everyday functional activities such as leisure, social connectedness, and community engagement. The entertainment value of digital interactions employing game-based interventions such as serious games, exergames, and gamification can provide additional therapeutic benefits for improving well-being. Furthermore, a recent review on the usage of service robots to help elders without cognitive impairment and with dementia reveals that interactions help elders to achieve independence in basic daily activities and mobility by providing reassurance and reducing stress. That is why the Aether Robot was created in a collaboration with the Developmental Disabilities Association, DDA. Aether is a socially assistive robot designed to help seniors and people living with developmental disabilities to achieve a higher degree of independence and to assist caregivers by alleviating the burden of care. The main use cases identified with DDA are safety inspection, where the robot searches for safety hazards or fallen people, and entertainment, where it performs cognitive stimulation activities. With the current access restrictions to DDA's facilities, we had to stop our in-site tests and our data collection and reinvent our processes. To overcome this challenge, we developed a simulator that employs virtual reality, or VR, to help us to test the robot. We created a virtual replica of a long-term care home from DDA for testing robot behaviors when navigating and interacting with a virtual avatar. Users can enter that environment to interact with the virtual robot by controlling avatars using a VR headset. The simulator also enables the generation of synthetic data for training machine learning models. It fosters the transfer of the knowledge built on the virtual environment, like the tuning of control parameters, to the real world. Our proposed system has a server computer, which runs the simulator written in Unity and communicates with the Oculus Quest 2 and the robot computer. The robot computer runs the robot operating system, or ROS, and the robot software stack that includes control, perception, and all other modules the robot needs. This architecture prevents CPU bottlenecks and ensures that the robot will have the same performance in the real world. This is a sample of the simulator, where you can see the setup with the robot and the avatar in the debug view. The user view shows what the user is seeing through the VR headset, and you can see that the user is able to control the avatar's head and upper limbs. Finally, the robot view shows the data ROS is receiving and displaying through its data visualization tool. Preliminary results show that the data from the real LiDAR, represented by the red dots in this image, is similar to that of the virtual LiDAR, represented by the blue dots. Both sensors detected the walls at equivalent distances, but some objects placed within the environment were detected with different distances. These differences were due to the misplacement of furniture within the virtual replica. The user could successfully control the avatar using the VR headset, and the robot sees the avatar's movement and obstacles through the RGBD camera and LiDAR. We also tested the EOLO object detection, which was able to detect the avatar and some objects in the scene. The integration of ROS with the Unity game engine allowed us to capture data suitable for simulating the robot's navigation and detecting surroundings, objects, and avatars in the long-term care home. An important limitation is that Unity's default extended reality framework supports only DirectX 11, whereas the Sensor SDK requires the ray tracing capabilities of DirectX 12. To overcome this, we adopted OpenXR. A byproduct of this project is the transfer of the virtual replica into virtual gathering spaces such as AltSpace VR or Hubs by Mozilla. These spaces have allowed us to connect with stakeholders to discuss various aspects of the project without requiring them to be co-located. We presented a virtual simulator that leverages robotics and VR for virtual navigation and human-robot interaction simulation. Our preliminary results indicate that the virtual sensor's data is suitable for virtually tuning Aether, and that the VR simulator reduces the need to physically access the long-term care homes and enables remote collaborations between all stakeholders in the decision-making processes. Future work will focus on evaluating our current person detection and fall detection modules, and on generating synthetic data to train the machine learning models that implement our perception system. Thank you for watching this presentation to the end. You can contact us at ether@3srp.com and find more information at 3srp.com. We thank the financial support of MyTax, AgeWell, JDQ Systems Incorporated and the Developmental Disabilities Association.